there exists a unique solvable ideal containing every other solvable ideal of L. And by the way, that has a name. The largest, the one that contains all others, all right? The largest solvable ideal is said to be the radical of L, and it's denoted rad L. All right, that's the radical of L. Now, so definition, here. A non-zero finite dimensional Lie algebra L is said to be semi-simple. Right, semi-simple if it has no non-zero solvable ideals. That is to say, the radical of L is 0. So a semi-simple algebra is one with trivial radical. So, and then there's like kind of an easy theorem. Here's an easy theorem. If you look at L mod the radical of L, that makes sense, right? Because the radical of L is an ideal. It's the largest solvable ideal, right? Then this is semi-simple. Basically, the idea of this theorem is very simple. The solvable piece of L, right? It's all contained within the radical. So you're taking L and you're making everything that's solvable 0 in the quotient, right? So of course the radical of this is 0. Now there is a careful proof given in the book, but that's kind of the what they call the yoga of it or whatever. But we don't do yoga here, right? None of that Eastern mysticism. So I'll stick with Western mysticism, MAGA, or something like that. Let's see. Or no, excuse me, what am I saying? Magaga, right? We've moved past Magaga. It's Make America Great and Glorious Again. So it's Magaga. I was hearing, but anyway, so that's pretty much the end of the section on solvable and semi-simple. I mean, there's much more to say about semi-simple. There's much more to say about solvable, but that's section 4.1. So I may come back, I may circle back and prove these next time if I think it's a good idea. I mean, these are so much fun to prove this stuff. Like this is all, it's all abstract linear algebra. It's I mean, that's part of the reason I wanted you to do this course, Audric, is like it's a good place to like hone skills and try to get, you know, a deeper understanding of like that part of linear algebra we never get to in the course, right? That's all of the linear algebra here is the part we don't cover in the regular course, right? Almost without exception. So anyway, this is a good place for us to stop for today. We'll be in chapter 4 again next time, I think. But I think as we go on in chapter 4, he'll start to explain, you know, the solvable part, the nilpotent part, and then the simple part, and then, you know, these set up the discussion for like the classification theorems, because there are beautiful, pretty far-reaching classification theorems for Lie algebras. Like we have a list of what there are out there. Once you set up the discussion properly, that is, of course, up to isomorphism as always. But anyway. Ooh. Did I make it? No, I made it 5 minutes over. This is going to be a stupid third video with 5 minutes of nothing. Oh well. Sorry, guys.